Alright, in this video we'll be talking about absolute value equations. To begin with, an absolute value equation it's just it's an equation that involves one or more absolute value expressions in it. The basic solution that we're going to use here is to split it up into two equations. Namely, we know that the absolute value of x, we haven't used this a bunch, but it's worth noting again. The absolute value of x is defined to be either positive x or negative x, depending on whether x is greater than or equal to 0 or x is less than 0. Namely, if we're to, to solve absolute value of x minus 2 equal 3, this actually gives us two equations. That is, we know x minus 2 could be negative, in which case x minus 2 would have to equal negative 3, because its absolute value is 3, or x minus 2 could be positive, in which case it would have to equal positive 3. Well, now we can solve each of these separately. We get x equal, by adding 2 to both sides, x equals negative 1, or x equals positive 5. So we would have two solutions. So let's look at a slightly more complicated example. Let's go ahead and solve this equation. So here, again, it's solved the exact same way. Let's write out the two separate equations it could be. Either absolute value of either x squared minus 3x is negative, in which case it would have to be the negative of whatever this value is, or or x squared minus 3x is positive, in which case it is just equal to that. Okay? But then, what does that tell us? Well, we can go through and solve each of these. We have x squared minus 3x. If we equals, let's go ahead and distribute that, 4x minus 6. Of course, here we still have the same thing. In both of these, let's go ahead and bring everything to the other side. Subtracting 4x, from both sides, we get negative 7x. And then adding 6 to both sides, we get this. Over here, on the other hand, we get, adding 4 to both sides, we get x squared plus x minus 6 equals 0. Both of these are very factorable, so x minus, here we have negative 6 and negative 1 will do the job. And here, factoring, we'd have x, what would work? Positive 2 and 3, yeah. Positive 3 and negative 2. X plus 3 and x minus 2. Okay. Again, in case you're rusty on your factoring, you're trying to find two numbers that multiply to that, but add to that. So here, negative 6 times negative 1 gives 6, but negative 6 plus negative 1 gives negative 7. Here, negative 3 times negative 2 is negative 6, but 3 plus negative 2 is 1. So this allows us to solve each of these. We know that one of these two parts then must be 0. This part will be 0 if x equals 6. This part will be 0 if x equals 1. This part will be 0 if x equals 3. And this part will be 0 if x equals 2. Here, let's go ahead and check just to make sure. Plugging 6 in, we have 6 squared times 6 squared minus 3 times 6. Absolute value, does that equal negative 4 times 6 plus 6? Well, here we have 36 minus 18, which gives us absolute value of 18. And absolute value of 18 is 18. So let's just leave it like that. Whereas negative 4, negative 4 times 6 is negative 24, plus 6. Something weird happened here. What happened that went wrong? Negative 24 plus 6, so that gives me negative 18, which is not a solution. So So this is not a solution. What about 1? If we plug 1 in, we get absolute value of 1 squared minus 3 times 1 equals negative 4 times 1 plus 6. Over here, we end up with, and is that a solution? Yeah. Here, 1 minus 3 is negative 2. Absolute value of negative 2 is 2. Here, on the other hand, though, we have negative 4 plus 6, which equals 2. So that is a solution. So 1 is a solution. What about over here? Plugging in 3 back into the original, we end up with 3 squared minus 3 times 3. Does that equal negative 4 times 3 plus 6? And the answer is no, it does not. That should be negative 3, sorry. So I need a negative 3 squared. Yeah, there we go. It should be negative 3. So negative 3. So here we end up with 9 minus 9, so we get 0 here. Does that equal negative 4 minus 3 is 12, plus that is 18, so that does not work. Not a solution. But what about 2? If we look at 2, we have 0, and if we plug in 2, we have 2 squared minus 3 times 2 in absolute value. And our question is, does that equal negative 4 times 2? So this would be negative 12. We get, negative 8 plus 2. That gives me a negative 2. Well, it doesn't matter what this is. This can't possibly be equal, so not a solution. So only one solution actually occurs here, and it is x equal 1. So only x equal 1 is a solution. And now it's time to have you try an example. So go ahead and try to solve this, and on the count of 3, and be sure to check your solution. On the count of 3, I'll reveal the answer. 1, 2, 3. And so we have here, notice I broke it up. Here's the negative, here's the positive. Breaking it up and factoring, I get 2 possible answers for each of these. But I have to go through and check all the solutions. Here, checking negative 9, we see it will not be a solution. Checking negative 2, we see it's not a solution. Checking 6, we see it is a solution. And checking negative 3, we see it is not a solution. So the only solution is x equals 6. For more practice in working with absolute value equations, be sure to see page A57 of the textbook and try out problems 85 through 88. In our next video, we'll be talking about intervals and inequalities.